Hello students, welcome to Umadevi Children Academy. Student, today we are going to discuss the new chapter. That is chapter number 5. Periodic classification of element. This is the last chapter of the chemistry subject. And the topic that we are going to discuss here, the Daubernier triads and Newland law of octaves. Yes, students. So this is our first topic from this chapter. Let's start the Daubernier triads. So the before going to start the chapter, we want to know that why we want to classify the element from the periodic tables. The reason is the number of elements were discovered, and it is very difficult to remember the behavior of these elements. Number of elements are discovered, so but as the number of elements are discovered, it is very difficult to find out the each individual property. Hence, the important to classify the element and to their property. It help to understand the how different element have a different forms different compound. For example, if the potassium and calcium are there, potassium, calcium, iron, all are metal. Potassium also metal, calcium also metal, iron also metal, but their property is different. The chemical reactivity of iron is high, chemical reactivity is higher than calcium and iron, right? And the valencies, calcium is 1, it reacts with only one species, it reacts with the 2 species, it reacts with the 3 species. So chemical reactivity also different here. So we want to classify that the whatever the elements are there in the potassiums or any XYZ element, we want to classify into the one table, one group, or some other elements are there which are exhibiting the similar chemical property. For example, the X exhibiting the similar chemical property of A, B, C. One more metal is finding Y which is exhibiting the similar chemical property of E, F, G. Like this, we want to classify the element. If you classify the element, during this classification, through this table we had easily determined that this group of the element which are showing the similar chemical property. By this group of element, with this group of the element which are exhibiting the similar chemical property. Right, friends? So that's why we want to classify the element. It is very helpful to understand the how different element from the different compounds. Right, friends? I hope you understood. Okay, first we are the classification element first was studied by the Daubernier triads. So earlier attempt, the elements are classified on the basis of the property. The elements were classified on the basis of their property. All the elements having the similar property put into the one group called family. The whatever the elements are there which are exhibiting similar chemical property, X, Y, Z. These elements are exhibiting the similar chemical property. That is we called as the similar. That is we called as a family. Right. Similarly, A, B, C, which are exhibiting the similar chemical property. This is the A family. This is A family, and this is X family. So that's why the earlier he classified the whatever the element which are exhibiting 2 or more than 2 elements which are exhibiting similar chemical property. So such element he considered as a family. Right, friends? So in German chemist, Daubernier observed that certain element had a similar property and he could put it together in 3 elements. He put the 3 elements, that is he called as a triads. All the 3 elements, the particular triad has a similar chemical property. So Daubernier, whatever he using the 3 elements, the first A, second B and C. So these elements which are exhibiting the similar chemical property, which are exhibiting the similar chemical property. So that's why he called as a triads. The three elements which are three elements combined to make one group, that is he called as a triad. And in this group, all the three elements which are exhibiting the similar chemical property. So Daubernier, the first scientist who showed the relationship between the property of the element in the atomic mass. He the first element. He is the first person who the step forward to explain that to elements. The elements there's the chemical property depend upon as increasing the atomic mass. How? I will show you the example, students. No problem. I will show you an example. Don't worry. The Daubernier law of triad, elements were arranged order of increasing atomic mass. Three element he called it the triads. Already I discussed. And this triad which is exhibiting the similar chemical property. Right, students? So that's why he given the one statement: atomic mass of the middle element of the triad being equal to atomic mass of the middle element. Middle element. I will show you the here the I am showing the A, B, C. That this is the middle element. Atomic mass of the middle element is equal to arithmetic mean. Arithmetic means the average. The average element, the middle element atomic mass is equal to the arithmetic mean of the two other element. The if A, B, C. These are the three elements. One triad. So B element atomic mass, which is equal to atomic mass of the A and C hold the average. The average atomic mass of A and C element average atomic mass is equal to atomic mass of the B. Right. Or one more statement: the middle element atomic mass is equal to average atomic mass of the first and last element. Middle element, for example, the middle element atomic mass is equal to B. B atomic mass is equal to the atomic mass of A and C, average atomic mass of A and C. Right, students? So either you explain this statement or this, both are correct, students. So example here, he make a triad. He make a first triad by using the alkali metal groups. Lithium, sodium, potassium have a similar chemical property, and these all are metal, and these all are liberating hydrogen gas and have a tendency. They have all of them have a tendency 1. It means they bond with one species. So what he did? So these are the similar chemical property. These are the similar chemical properties of sodium, potassium, and lithium. So just look at due to the similar chemical property of the element, he put into the same group, and his statement is middle element is sodium. Middle element atomic mass is equal to average atomic mass of the first and last element. First element is lithium, last element is potassium. So he using the atomic mass is lithium is 7 and sodium is 23 and potassium is 39. So if we use the sodium atomic mass, we want to find the sodium atomic mass. So it means the atomic mass of lithium plus atomic mass of the potassium whole divided by 2. So put here, students, sodium is equal to atomic mass of lithium Li. Lithium is 7. I am putting here 7 plus atomic mass of the potassium is 39 whole divided by 2. Then how much we got? The answer we got here, the 46 whole divided by 2, that is 23. So 23, that is the atomic mass of the sodium, here also 23. So it means he concluded that the central element or middle element the middle element atomic mass is equal to first and last, the average atomic mass of the first and last element. Right, students? This is he prepared the first triad. This is we called three elements in one group. He called as a triad. Why he kept into this one group? Because these elements which having the all are metals, all are liberating hydrogen gas, all have a tendency 1. After the alkali metal alkaline earth. After alkaline metal, the second example using the alkaline earth metal, calcium, strontium, barium, all are the similar chemical property. How the similar chemical property? Because all are metal, all are alkaline, the all these oxides are alkaline nature, and they have a tendency of valencies too, right? So these elements all are metals, and they forms oxides, and they forms oxide with alkaline natures. Calcium oxide react with water to form the calcium hydroxide, like this is alkaline nature. So I have a tendency 2, all are having the valency 2, right? So that's why the calcium and strontium and barium he kept into one single group, because they are having the similar chemical property, and this is we call it the second triad. This is the second triad. Daubernier statement. Here the middle element strontium, middle element is the strontium. Strontium atomic mass is equal to average atomic mass of calcium and barium. Look at here, I am using here strontium atomic mass of, I will show you just 80, atomic mass of calcium plus atomic mass of barium whole divided by 2. So atomic mass of calcium is 40, and barium is 137 whole divided by 2, then we got the 88. So 88 is the atomic mass of the strontium, which is more or less equal to the strontium atomic mass, correct? So here consider the 88 is there, this 88 is more or less which closer to the 87 atomic mass of the strontium. So this is the strontium atomic mass here 88, this atomic mass 88 atomic mass, which is more or less equal to the strontium atomic mass. Understood? Okay. Halogen, the third triad he prepared, that is halogen, chlorine, bromine, iodines. These three elements, why these three elements are kept into one group? Why this element called as triad? Because they are non-metals, because they are liberate acids, because they are have one valency. So that's why this property are remains same. So in Daubernier triad, middle element atomic mass equal to average atomic mass of first and last element. So chlorine, iodine, first and last element. Bromine is the middle element. So middle element atomic mass, I am using here the middle element atomic mass here, middle element atomic mass 35.5 atomic mass of chlorine, and the 126.5 atomic mass of iodine. The average atomic mass is 81. So this 81 atomic mass more or less equal to the atomic mass of the bromines. Right, friends? So the Daubernier he made the one of the third triad by using the halogen element. Understand? Okay. So invitation, it was failed to arrange all the element in the form of triad having similar chemical property. So it was failed. This theory was failed. Why this theory was failed? Because he arrange the known element only. What are the elements are available at the in the year of the 1863 or 75? At that time, the such type of the metals only he make the triads, right? Second one, he unable to make more than 3 triads. He unable to make the more than 3 triad, students, right? Understood? And so that's why this theory going to be failure. He made the triad, first point, he made the triad only those element he know that element, he was know that element. Second one, he unable to make the more than 3 triads, as the new element was invented. So he unable to make that element triad. So that's why this theory going to be fail. Newland law of octaves. Newland is more fascinated about the music tone. So like this, when you see that, students, sa, in music tone sa re ga ma pa da ni sa, first music tone is sa and the last music tone also sa. It means the first and the the first stone repeated after the eighth position element. Right. So similarly, the Daubernier states that the elements he arranged on the basis of the atomic mass. Elements arranged on the basis of the increasing atomic mass. And instead he found that first element and the every eighth element properties are remained same here. First element and the eighth element property remains same. So his statement is given: the elements were arranged in the basis on the basis of the increasing atomic mass, on the basis of atomic mass, and the property of the eighth element repetition of the first element. The property of first element and the eighth element. In between them, the 2, 3, etc. are there here. The property of the first element and the eighth element, the property remains similar. Right, like musical tone. This statement according to the musical tone. The first element is sa, second is re, ga, ma, pa, da, ni, sa. So first element and the eighth element. This is 8 students. First element and the eighth element have a similar chemical property. Right, students. So like this, he made one table here. This is the table made by the Newland. So in this, the musical note is there: first, second, third, fourth, up to eighth. So look at here, musical tone, Indian musical tone, sa, re, ga, ma, pa, da, ni, sa. First tone is musical tone is sa, and the eighth also sa. Both have a similar chemical property. It means he said that the first element and the eighth element have similar chemical property. Right, students. So here the first element, consider the helium is the first element. Then eighth element is first, second, third, fourth, fifth, sixth, seventh. So first element hydrogen, eighth element is oxygen. Sa, re, ga, ma, pa, da, ni, sa. Right. So similarly, if we consider lithium is the first element, then this is second, third, fourth, fifth, sixth, seventh, eighth. Sodium is the eighth element. Right. So lithium, if you consider lithium is the first element, then eighth element is sodium. Similarly, if you consider the beryllium is the first element, then this is second, third, fourth, fifth, sixth, seventh, eighth. Magnesium is the eighth element. Right. So lithium and beryllium and magnesium are the eighth element. Right. If you consider boron is the first element and the eighth element is aluminium. Right, students. And the carbon is the eighth element, first element, and their eighth element is 1, 2, 3, 4, 5, 6, 7, 8. Silicon is the eighth element. Both are exhibiting similar chemical property. If nitrogen is the first element, then 1, 2, 3, 4, 5, 6, 7, 8. Phosphorus is the eighth element of the nitrogen. If so, oxygen is the first element, then second, third, fourth, fifth, sixth, seventh, eighth. Sulfur is the eighth element of the oxygens. Similarly, fluorine is the first element, then chlorine is the eighth element. Sodium is the first element, potassium is the eighth element, magnesium is the first element, calcium is the eighth element. Right, students? So this he prepared. But when you compare the aluminum chromium property, the aluminum property and the chromium property are not matched with each other. Here here whatever the elements are present here up to calcium, the every first element and the respective eighth element property are similar, but aluminum, chromium, silicon, tin, phosphorus, magnesium, sulfur, iron, these properties cannot match with each other first element. So here look at here, lithium first element, the sodium is the eighth element of lithium. Sodium first element, potassium is the eighth element of sodium. Right, and they are exhibiting similar property. Beryllium first element, magnesium is the eighth element of beryllium. Manganese first element, calcium is the first element of magnesium. Right, so he prepared like this, but this theory applicable up to calcium. After calcium, that did not possess the similar chemical property. I told you the aluminum property is not matched with chromium. Silicon first element and lead property, titanium, not matched with each other. phosphorus magnesium property not match with each other, sulfur and iron property are not match with each others. Right, students? So limitation, this theory applicable up to calcium only because the property is not similar. Second, at the time the 56 element was found, and Newland explained that the only 56 elements are present in the universe, not more than 56. But as the different scientists are inventing the different element, so this theory is going to be again fail here. So and he put the cobalt and nickel in fluorine and chlorine positions. Look at here, the cobalt and nickels are the metal, but the fluorine and chlorines are the non-metals. These are the non-metal and this is the metal. He could not explain the why the metal cobalt nickels are kept into non-metal groups. He could not explain because and their property also different here. He could not explain that one, right? And he could not explain that why iron property, the iron property is similar to cobalt nickel but could not kept into the iron slot. So irons are kept into sulfur group. Sulfur is a non-metal, iron is a metal. He could not keep these cobalt nickel property and iron property are similar, but he kept into different slot. It is in a first group, it is in a 8th group. So that's why this theory again fails, students. Right? Students, okay, today this is a today topic, students. If you find any doubt, ask me, students. Thank you so much.